Okay, so in this video we're going to review color and light and electron energy, right? So remember, these are our Bohr models of an atom right here. Uh, so this is all the same atom, it's just showing different states. So we call this the ground state. This is important. This is a normal atom where all the electrons are in the lowest energy level. So this would, for example, since it's 2 electrons, this would be a helium atom in its ground state. Now, what we can do is we can add energy, okay, and this gets the electrons excited, makes them dance around and jump up an energy level, right? And so now we can see one of the electrons is still in the lower ground state, but this electron's excited. It's in the second energy level. It's higher up. Now, when the electrons are up here, this isn't stable. It doesn't want to stay up here forever. Eventually, it's going to fall back down, and that's what we see here. As it falls back down, we see that the energy is now released. So what we have here, this excitation, is we're adding energy in to the atom. And there's a bunch of different ways you can do that. I've shown you a few ways. One is to add electrical energy, right? Add a ton of voltage. Another thing we've done is light it on fire, right? Fire plus heat. And there's other ways too. There's like mechanical, which is just a fancy way of saying hit it really hard. Mechanical, I think I spelled that right. And I'll show you one of those eventually as well. I have some materials that can do that. So there's a bunch of different ways to do this, but all of the idea here is that you're adding energy into an atom. And so this energy goes to excite the electron, right, as the energy goes in. And then eventually, as the electron calms back down, right, the idea here, energy is not created or destroyed. So as we add this energy to the atom, it's still there, right? It's just potential energy now, just like when you pick something up off the earth, right? You're adding potential energy to it. As it drops back down, it releases that energy. And then that energy, of course, is light. And if it's light we can see, it'll have a color. And that's basically where color comes from. It's electrons dancing back and forth between these energy levels. Let's just review a couple different models so we can see this a few different ways. So again, this would be our ground state electron, and then as we add energy, so this time they're adding light energy. That's another form of energy we could add. Usually, you could do it without all kinds of light energy, but UV light is very common. We'll talk about that in a minute with fluorescence. So you can add light energy. That's what a photon is, and so we get to this higher energy state, right? So by the way, this step here does not create color. It actually destroys it for a second, right? We actually miss the colors that get absorbed. So as we're adding energy, as we're lighting on fire, as we're adding electrical energy, all that energy is actually being absorbed, and so it's kind of missing. We're not seeing it. So what are these colors that we see? Like when we did the flame test, or when I excited these gas tubes. We're not seeing the energy that's being absorbed, we're seeing the energy that gets released, right? So as the electrons fall back down to their ground state, they have to give off that energy, right? And so we can see here, I like this example because we can see now, this electron was here, it fell back down here. That's a pretty small jump. This is like dropping a rock from a small distance. It just releases a little bit of energy. And so we get a longer wavelength. Because energy and wavelength are opposites. The low energy is a long wavelength wave, and then we know that red tends to be our longer wavelengths, right? So this is how we make a nice red color, small little energy jumps. What if we drop from a little bit higher energy level? Well, we're going to be a little bit more energy, so our wavelength is going to be a little bit smaller, and we're going to get, in this case, a nice kind of light blue color. And then what about a really big jump, right? So we're going all the way from energy level 5 to energy level 2. So it's a large jump, a lot of energy being released. So we get this really short wave. So this is kind of a blue, almost getting into a blue-violet even. So remember, blue and purple are our high energy colors, right? With red being low. So this, and this atom can do this, right? This would be a hydrogen atom. I think this is what we're seeing. Yeah, see these patterns here? This is hydrogen. So you wouldn't get all these from one hydrogen atom, but because we have millions of hydrogen atoms, we see all of these colors when we diffract the light for hydrogen. Okay. You've also learned about electron configuration and electron orbital diagrams. That's kind of the new way of showing electrons, right? So this is a ground state. There's 4 electrons, so this would be beryllium. We know that because it's number 4 on the periodic table. So the way we show ground state for this is that all the electrons are filling the lowest possible energy levels. By the way, just real quick, this would be the same as, right, so we have beryllium, okay. Okay. So when we're looking at these electron diagrams, it's actually, it's a more modern version of this. So these first two electrons are kind of like when we draw that first energy level. These two electrons here are occupying that second energy level, right? So that's what we're seeing there. So if this is the ground state and it gets to this excited state over here, is energy going in or out here? Hopefully we all see this now. Energy is going in. Energy is going to go in and smack into one of those electrons and give it its energy, right? And that's how we get over to this excited state. So again, at this point, right, we add some fire, some electricity, some UV light, we get the electron excited. We don't see anything at this point. It's not until this one falls back down, right? So as this one falls back down, right, that would then release, and I'm actually going to draw a red energy line coming out. And this is when we see the color, right? It's when the electron's falling back down to ground state that we see the color, okay? So release of energy. I drew it red because this is a small energy jump. They're both in energy level 2. It's just going from p orbital to s orbital. This is a very low energy jump. It might not even be red. It might even be like infrared or something. So that's where we see the color. What about black lights? How does fluorescent work? So again, it's all about electrons dancing around, okay? We're definitely adding some energy. But again, there's a lot of different energy orbitals, right? So this is like 0, ground state, right? S1, S2. So as we add energy, the electrons don't always fall all the way back down. Sometimes they take these weird paths, and so they drop to these small energy levels, and this small energy, and this small energy, then they make a big jump. Well, once they make this big jump, remember, they already lost this much energy. So this big jump that they make is not going to be ultraviolet anymore. Remember, ultraviolet is really high energy. So now that they've lost some energy, right, they're going to shift over on that electromagnetic spectrum and emit a lower energy light. Well, what happens to be right next to ultraviolet on the spectrum? Visible light. And so this fluorescent and visible UV light eventually turns into a green or an orange light. And that is how black lights work, right? Not everything does this. Some things, emit other colors. But that is basically how we get a black light or, dude, shush. And that is how we get a black light. I apologize for that, his coworker. But that is how we get a black light to work. It's just dropping a little bit of energy levels, and then, yeah. So we'll just end the video there because I got a bunch of annoying coworkers coming in now. So make sure to like and subscribe. Thank you.